Today we're going to look at solving right triangles. So a lot of people learn SO, CA, TOA to remember the ratios, which basically means that sine, if we're thinking about right triangles, remember we have three sides. So across from the 90-degree angle is always your hypotenuse. The side that is attached to the angle you're coming from is adjacent, and the side across from the angle is opposite. So you have to be very careful and pay close attention to which angle you are referring to. So for sine, it's always the opposite over hypotenuse. For cosine, it's the adjacent over hypotenuse. Remember to be careful which angle you're coming from because it will make a difference. And tangent is opposite over adjacent. Now we do have their inverse functions. We're not going to do a ton with those while we're solving, but we will use those later when we're applying them to pre-cal. So cosecant is the inverse of sine, which would mean it's hypotenuse over opposite. Secant is the inverse of cosine, which means it's hypotenuse over adjacent. And cotangent is the inverse of tangent, which means it's adjacent over opposite. Now the other thing that we need to review is the Pythagorean theorem, and we are going to apply that to this. So with the Pythagorean theorem, remember anytime that you have a right triangle and you have two of the sides and you're trying to find the third, you can use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Your c value always being the hypotenuse, which is the biggest side. So for this one, across from that 90 degrees is my 5, which is my h, or for this, my c value. So I have x squared plus 4 squared equals 5 squared. I'm going to solve it down. X squared plus 16 equals 25. Subtract that 16 over, we get x squared equals 9. Square root both sides, and x equals, technically when we're solving it's plus and minus, but we can't have a negative for a side length, so it's 3. And there's your missing side. So here's how this applies to what we're doing now. If I tell you that the cosine of theta is 20 over 29, I want you to tell me what the sine of that same angle is. I would suggest drawing a triangle. So if I draw a right triangle right here, choose which angle you want to come from. It really doesn't matter. I'm going to come from this guy right here. So that means cosine is adjacent over hypotenuse. So attached to that angle is 20. Across from 90 is 29. Well, if I need sine from that same angle, I'm going to have the opposite, which I don't know. How do we find the missing side? We can use Pythagorean theorem. So I have 20 squared plus x squared equals 29 squared. So I'm going to plug that in my calculator. 20 squared would be 400. And 29 squared would be 841. I'm going to subtract that 400 over to get 441. And if I square root 441, I get a lovely 21. So now I have that missing side. So my sine of theta would be the opposite, 21, over the hypotenuse, 29. Go ahead and pause the video and try number 2. All right, so number 2, again, I'm going to draw that triangle. Here's my right triangle. Pick which angle you want to come from. Secant. What was secant? Secant is hypotenuse over adjacent. Well, my hypotenuse, that means that's 13. And adjacent, so attached to the angle, is 12. I need tangent. Well, tangent's opposite over adjacent, so I'm going to have to find the other side. So I have x squared plus 12 squared equals 13 squared. That simplifies to x squared plus 144 plus 169. I'm going to subtract that over to get x squared equals 25. So x is 5. Which means tangent from that same angle is opposite 5 over adjacent 12. All right, let's review solving. So we have two types of solving. We have solving for sides and we have solving for angles. They are a little bit different. So if you don't have a calculator, go ahead and pull one up or go out to desmos.com/scientific. All right, so for this first one, we're going to solve for the side. Now, when we're solving for right triangles, or with trigonometry, you have to be coming from an angle that's not 90. So you're either coming from a missing angle and solving for that angle, or you're coming from the angle it gives you. So I can't come from 90. So I'm going to circle the angle that it does give me, which is 23, and I'm going to label my sides accordingly. The side across from 90 is the hypotenuse. The side attached to this angle is adjacent. So which trig function uses adjacent and hypotenuse? Cosine. So I have cosine of the angle equals adjacent over hypotenuse. And then you're going to solve. I like to look at the solving kind of like cross multiplying. So I have x cos 23 equals 5 times 1 is 5. I'm going to divide by cos of 23. So when I plug that into my calculator, I have 5 divided by cos of 23. That gives me 5.43. That's my answer. Okay, go ahead and pause. Try number 2. All right, on this one, it gives me the angle of 54, so I'm going to circle it, label my side. So attached to that side is my adjacent. Across from that side is my opposite. So O and A would be tangent. So I have tangent of 54 equals the opposite 10 over adjacent. I'm going to cross multiply again to get x tan 54 equals 10 divide, and when I plug that into my calculator, I get 7.26. All right, let's look at solving for angles. This one's a little bit different. So solving for angles, we're going to circle the angle that we need to find. It's not going to be our 90-degree angle. So I'm going to circle this x and label my sides. So that process is still the same. So for this one, I have opposite and hypotenuse. O and H, opposite and hypotenuse, would be sine. So I have sine of x equals opposite over hypotenuse. Now, since that x is an angle, it's inside the function of sine. To get rid of it, I'm going to have to do the inverse. I'm going to have to do this -1. If you look at your calculator, you'll see that button on top of your sine, cos, tan buttons. Okay, so when you plug that in, you're going to hit your second sine. That gives you sine -1 or inverse sine of 17 divided by 23. If you're in degrees on your calculator, which you should be, DEG should be somewhere written on there, you should get 47.66. Go ahead and pause and try the next one. All right, on the next one, I'm going to circle the angle that I need, and I'm going to label my side. So I have adjacent and hypotenuse. So for this one, A and H would be cosine. So I have cosine of x equals adjacent 35 over hypotenuse. Again, my x is an angle. It's inside the cosine function, so I'm going to have to take the inverse of it. And I'm going to plug that in. So my second button, cosine of 35 divided by 43, and that should give you an angle measure of 35.52 degrees.